Okay, now we will talk about oogenesis versus folliculogenesis or follicular development. Oogenesis starts first in the embryonic life. It means in the fetal life of the female. Then it continues at birth till childhood, till puberty, and then stops at menopause. Menopause is the age at which the female has no more cycle, has no more oocyte, which is from age 40 to 50. Okay, first the oogenesis starts with oogonium. Oogonium is a germ cell. It is a germ stem cell. It has two N chromosomes. It is a diploid cell. Oogonium in singular, oogonia in plural. Okay, we have oogonium that undergoes multiplication phase or mitosis. This is the multiplication phase or mitosis, and we have here the oogonium undergoing mitosis and several mitotic divisions in order to give about 700 million oogonia. It means in order to increase in number. So this oogonium undergoes mitosis to increase in number. This is the first phase of oogenesis. It is called multiplication or mitosis. So this phase occurs during the fetal life of the female. It means when the female is a fetus. This is the multiplication phase. Now we have many oogonia with two N chromosomes. They are diploid. Okay, now this oogonium will undergo the second phase, which is the growth phase. It becomes a primary oocyte. The primary oocyte now here, as you can see, it has a larger size. So the oogonia undergoes the growth phase to become primary oocyte that is larger in size. Also, this phase occurs during the embryonic life. This is a primary oocyte with two N chromosomes. Now this primary oocyte will start meiosis 1. Now we will start with meiosis, and it is the oocyte is blocked at prophase 1. This is the first arrest that I've talked about in the previous slides. So this is the first arrest, oocyte 1 blocked at prophase 1. It means it starts meiosis 1 but blocked at prophase 1. Now birth occurs. Okay, this is at birth. So at birth of the female is born with oocyte 1 blocked at prophase 1 and with primordial follicle. We have no development here of follicles. Okay, so the birth of the female is accompanied with oocyte 1 blocked at prophase 1 and a primordial follicle surrounding this oocyte. Okay, now this is a period of childhood. It's about 10 to 11 years. The ovary is inactive. Okay, we do not have any changes. The primary oocyte remains and the primordial follicle remains. Now puberty, the age of 12 to 13, the female is now mature and she will have every month a cycle. So we have, as I've said before, every cycle, 4 months before this cycle, we have development of the primordial follicles till it becomes tertiary, and in the cycle we have meiosis will continue. Okay, now we are working every cycle, the same thing will occur. So the primary oocyte will continue meiosis 1. It is blocked at prophase 1. It continues meiosis 1 to give two daughter cells that are not identical. Okay, these daughter cells are not identical. The first polar body having N chromosomes will die. It may multiply here, but it will die later on, and it is small in size. And the secondary oocyte or oocyte 2 also has N chromosomes. Okay, and chromosomes with two chromatids here because it is meiosis 1. So we have a secondary oocyte, and during this time we have development of the follicle till it become mature follicle. And this occurs during every cycle. Okay, and then the secondary oocyte now, it is called oocyte 2. It is released here at ovulation at day 14. Okay, and here it is important to note that before a few hours of the ovulation, few hours before the ovulation occur, the oocyte 1 continues this meiotic division and give the oocyte 2, and the oocyte 2 it is blocked at metaphase 2. Starts meiosis 2, but it is blocked at metaphase 2. Okay, here the primary oocyte remains until we have day 14, At day 14, it continues this meiosis 1 and gives oocyte 2, and oocyte 2 starts meiosis 2, but it is blocked at metaphase 2. It is released by ovulation at day 14. Okay, now we have oocyte 2, which is released by ovulation. This oocyte 2, we said that it is released to the fallopian tube. Now we have two cases. If the oocyte which is released into the fallopian tube is not fertilized, it means if fertilization doesn't occur, and then this oocyte will remain at metaphase 2, it will not continue the meiosis, and it will degenerate after 24 hours in the fallopian tube. Okay, oocyte 2 will not continue the meiotic division and will die after 24 hours in the fallopian tube if fertilization doesn't occur. But if fertilization occurs, this oocyte 2 will continue the meiosis 2. It will continue anaphase 2 and telophase 2 if fertilization occurs, because fertilization allow or it triggers this oocyte in order to continue the meiosis. Thus, this oocyte will continue the meiosis to give the second polar body and the ootid or the fertilized ovule. They have different sizes, they are not identical, and the second polar body will degenerate later on. So we have the ootid, which has the N chromosomes, with the sperm, which has N chromosomes. It will give us the zygote having 2N that will start its first mitotic divisions. It will start the mitosis. This is the zygote. Okay, so only if the oocyte is fertilized, it will continue meiosis 2. It means that fertilization allows the oocyte to continue meiosis 2 and to give the fertilized ovum or ootid. And at the end of the cycle, we said that the ruptured Graafian follicle becomes corpus luteum and it will degenerate. And here, in each case, there is a consequence. In the first case, in which there is no fertilization, the corpus luteum will degenerate at the end of the cycle. It means at day 28. But if fertilization occurs here, okay, then the corpus luteum will remain 3 months of pregnancy. It will not degenerate, because if fertilization occurs, then we have pregnancy. Thus, the corpus luteum will remain 3 months of pregnancy, because it is important in the pregnancy. Okay, it means corpus luteum degenerate at day 28 of the cycle if there is no fertilization, but it remains 3 months of pregnancy if there is fertilization. And it is important to note that during childhood we have follicular atresia. Follicular atresia is the degeneration of follicles. It means from these follicles there are many that will degenerate during the period of childhood, but the number will stay high because we have millions of we have many follicles. About 400,000 follicles will remain, okay, and millions of oogonia. Okay, so oogenesis has 3 phases in case there is no fertilization, and it has 4 phases in case there is fertilization. They are the multiplication or mitosis, the growth, the maturation or meiosis. This is okay, and the 4th phase in case there is fertilization. It is here the development of the zygote. Okay, there are 4 phases in case of fertilization and 3 phases in case there is no fertilization. This is a summary of oogenesis and folliculogenesis with the cycle of the female, and we start with multiplication phase or mitosis. During the embryonic life, okay, multiplication occurs where oogonium germ stem cell, diploid cell, undergoes several mitotic divisions in order to increase in number. We have millions of oogonia are produced. They are also diploid, having 2 N chromosomes, and they undergo growth phase. Okay, in growth phase there is enlargement in size, and we have here the oocyte. It is oocyte 1, okay, having 2 N chromosomes, and of course here the oocyte 1 will then start meiosis, and it undergoes interphase, of course, before the meiosis. Then meiosis 1, it is blocked at prophase 1. We've said that oocyte 1 is blocked at prophase 1. Then we have birth, period of childhood, 10 years, where oocyte 1 remains blocked at prophase 1, and the primordial follicle, it is present. We have about 400,000 primordial follicles that are present, and oocyte 1 is blocked at prophase 1. Then we have the cycle at puberty. The cycle will start every month. We have a cycle, and every 4 months before the cycle, about 10 follicles will start to develop, but only one will become the cavitary follicle. Primary, secondary, then cavitary follicle. Only one will become cavitary. The cycle starts, it is 28 days. The cavitary follicle becomes Graafian follicle, and here a few hours before ovulation, which is at day 14, we have the oocyte 1 continues meiosis 1 to give oocyte 2 and the first polar body. The first polar body degenerates, oocyte 2 is released by ovulation into the fallopian tube. So ovulation will occur no matter of the result, no matter if there is fertilization or not. Ovulation occurs. So oocyte 2 is released into the fallopian tube. It survives 24 hours. If there is no fertilization, it dies. Okay, if there is no fertilization, the oocyte 2 dies after 24 hours, and the ruptured Graafian follicle will become yellow body or corpus luteum. Then it becomes white body or corpus albicans, and then it degenerates. Okay, at the end of the cycle, this is the luteal phase, and before day 14, it is follicular phase. Okay, if there is fertilization, now oocyte 2 will be fertilized in the fallopian tube. Okay, so fertilization occurs in the fallopian tube, and the fertilization allows the oocyte 2 to continue meiosis 2 and to release the second polar body and the fertilized ovum or oocyte. So only fertilization allows the oocyte 2 to continue meiosis 2. If there's no fertilization, it will not continue the meiosis 2. Okay, fertilized ovum is produced. We have 2 N chromosomes because N from the sperm and N from the ovum. We have the embryo. The embryo will start its first mitotic division and will develop in the uterus. Okay, this is the folliculogenesis versus the oogenesis. And in case of fertilization, the yellow body, okay, that is formed from the ruptured Graafian follicle becomes corpus luteum or yellow body, survives 3 months of pregnancy. It means it doesn't degenerate directly if there is fertilization. It survives 3 months, and then it will degenerate after 3 months because it is required during pregnancy.